Okay then, let's talk through what this evidence actually shows us. So the first piece of evidence we looked at was the geological jigsaw. It's perhaps the most obvious of all bits of evidence that Wegener used. This idea that the continents fit together. We see it perhaps most obviously with Africa and South America. You know, the shape of the coastlines there look fairly similar. But we do see that the coastlines themselves don't actually fit. Where we get a better fit is at the edge of the continental shelf. The continental shelf is the shallow bit of the sea that surrounds the continents. It's continental crust, but it's just below sea level, maybe a couple of 100 meters at most. The edge of the continental shelves is a much better fit. There are still gaps, though, probably caused by erosion. Some areas of overlap where over time new rocks have been deposited. But overall, the fit is too good really to be a coincidence. So we can explain away the small issues with this data, but it gives us a strong indication that these continents were both together. But on its own, it's not enough. If we start looking at the geology uh, of these two continents, of Africa and South America, we start to see more things fitting together. So it's not just the edge of the continental shelf, but we also see the rocks on both sides of the ocean also fitting together. These areas of ancient continental crust, the continental shields we call them, or cratons is another word we use, they also fit together. Now, for both of these continents to have the same rocks forming at the same time, with an ocean in between them, becomes very unlikely. If we then add in the mountain belts, which also fit together, that increases the unlikelihood of these two continents having been separated when both of these things formed so far apart in time. The chances of the same types of rocks forming 2,000 million years ago on two widely separated continents, and mountain belts 500 million years ago also forming separately, but that also happen to fit together, is really, really unlikely. It becomes very, very hard to explain away the whole series of these connections between the continents without them having been together. If we look in even more detail at the geology, and we actually look at the fossils that we find, we've got a whole series of organisms here, three of which only lived on land. Cyanonathus, Lystrosaurus, Glossopteris are terrestrial organisms. Now, for those animals to live at the same time on continents that are entirely separate, these animals can't swim the ocean. Even Mesosaurus, which is a marine organism, only lived in shallow water. So the chances of all of these migrating across oceans that are now thousands of kilometers wide at exactly the same time is almost impossible to explain. Even if we try and argue that these animals could have migrated, if you like, the long way round, from Africa through Asia, across a land bridge in the northern Pacific, down through North America into South America. That's a very long journey that leaves no fossil record. Yet we do find fossil records of these spread across um, these continents that we interpret as being together. In the past, suggestions have been made about land bridges existing, these strips of land that would have joined these continents together. Now, that does happen at times, where you get a chain of islands, like the Aleutian Islands in the northern Pacific. If sea level's lower, the gap between those islands reduces. Here in Britain, um, during the height of the last ice age, when sea level was lower, there was no water between us and mainland Europe. But we're talking here about Africa and South America. This is where we have a continent, we have a whole ocean that's kilometres deep. That where would that land bridge have come from? And perhaps more importantly, where is it now? There's no geological trace of anything like that across the width of that ocean. It simply didn't exist. We can also start thinking about the climate. If we look at the distribution of some of these organisms, particularly Glossopteris, and we look at the present day environments where we find this plant um, in the rocks, we've got temperate climates in South America. We've got desert climates running through Africa. We've got equatorial climates in southern India, real tropical stuff. We've then got glacial climates in Antarctica, going into a desert in Australia. The huge range of climates there, about the full range that there is, and the distribution we see of the Glossopteris fossils, there's no way they could have grown in all of those different environments with the continents in their present position. The only way to explain it is that those continents were once together and had a far more similar climate to each other. If we take that climate argument a step further, and we look at the records of glaciation, if we look at the places now that show evidence of this great glaciation at the end of the Carboniferous period, we're trying to explain why we have glaciers covering a large amount of India, but not covering northern Australia. It makes no sense when we look at modern day climate distribution in these widely spread apart continents. If though the continents are together, this glaciation makes far more sense. India, for example, is far more to the south than it currently is. Also, if we look at the distribution of these glacial scratches, the movement of glaciers within this glacial event, we can see that by putting them together, those directions again make sense. We've got clearly a centre of glacial growth in southern Africa, probably in Antarctica as well, although it's harder to get this evidence from Antarctica, with those glaciers moving outwards from that point. So if we put all this together, as we watch the sunset over Table Mountain in Cape Town, one fragment of this broken continent, when we put all this evidence together, it really strongly shows us that the continents were once together and have now been broken apart. Wegener was convinced that this was evidence that the continents must have drifted. But his theory had a fatal weakness, a reason why people didn't believe him. And that was his lack of a mechanism. He knew the continents had moved, but he could not explain how they moved. And it's only once that puzzle was starting to be resolved that plate tectonics became a more widely accepted theory. So what we need to do is look at how Wegener's theories were developed by the collection of more evidence to try and show how these continents actually move around the surface of the Earth. But that's for another lesson. I'll see you then.